Hi, everyone. My name is Praveen, and welcome to Skilled Inspirational Academy. So I'm working as a senior network engineer, and I have over 10 years of experience in networking. So my role resides with implementing and designing the network infrastructure, and I'm in the advanced troubleshooting team, where we have the escalated cases, maybe more cases with slowness issues, performance issues, and there may be some problem with the design constraints, and we are doing more migrations. And I am working on SD-WAN projects now, and I have my expertise in wireless routing and switching. And my proficiency I also leverage to OSPF and BGP. And the difference in my team is we do a lot of analysis with Wireshark. So that helped us to figure out a lot of issues, because people, they might be doing troubleshooting for a week and they couldn't figure out where the problem is. But with Wireshark, we could find maybe in 3-4 hours, we'll do a deep packet analysis and we'll go by layer, and we'll replicate the issue and we'll try to figure out the problem. So my roles and responsibilities is more with troubleshooting. And to start with, this course is a combination of Wireshark and basics of networking and security. So let's go one by one. So in the basics of networking, we all know about OSI model and TCP IP model. So here we stand out with using a Wireshark, and we'll show you how exactly the packet exchanged. But even people can do that, but sometimes they cannot follow the sequence. So where I have to start, and what exactly I have to look in. So here we will give you, we will dwell into the layered approach. We'll peel off on every layer and we'll see, so what this particular layer is doing here and where is the problem. And we'll do the, topologies and how this communication is happening. Example, if you type www.youtube.com right from your physical layer to your application layer, we'll look into, okay, how packets are exchanged and what exactly I should see. And you will give, we will get more understanding about every single layer. So followed by that, and we will also learn about the functions and protocols. We all know every communication happening with protocols. Protocols are well defined. Example, if we say routing protocols, OSPF and BGP is a predominant routing protocol that is used for SD-WAN architecture. It's not only that. So I would say, if you are very good with OSPF and BGP in a very deep level with packet level understanding, then it's just a cakewalk for you to troubleshoot any kind of issues. So we'll go for every protocol, not only limited to OSPF and BGP. It's a layer 3 protocols. So we'll also discuss about layer 2 protocols and what is 802.1q, what is VLANs, and what are the other protocols used in the upper layers. So also coming to that, the other more key protocol that's been widely used, that is TCP. We all know that most of the reliable applications all using a TCP. So we will have a very detailed study about TCP, and what is sequence number, what is acknowledgement number. So what are the other headers in the TCP? So we will discuss that in the functions and protocol of each layer. And we will look about how exactly the encapsulation happens and in the sender side, and how the decapsulation happens in the other side. And we will see for every interface, right? So in every interface, you have an interconnect between two devices. So you should have your duplex. It should be, if it is a full duplex, you have a full connection and your performance is good. If there is a half duplex connection, both devices cannot send it at the same time. So there will be a problem there. So how I can find the duplex issue? Because of the duplex issue, your input errors may increase because of duplex, because one device can send at a time. So in the lab, we will see how to see that. Most people, they are experienced and they'll be doing it, but I mean, the people who are experienced, they can ignore this. This is for beginners who never heard of what is duplex. So duplex mismatches, one end is configured with full duplex, the other end is configured with half duplex. Then will be a duplex mismatch, and how we are going to find out in the interface level, and how we see the link speed, and we will differentiate between the throughput and bandwidth. Most people, they confuse about what is bandwidth and what is throughput. So we will, do a case study, and we will understand what is throughput and what is bandwidth and what is auto negotiation. So now the ports are very smart. I mean, back in 20-25 years back, it's not an auto negotiation because of this MDIX protocol. When you just plug in your cable, the switch decides. Yeah, but earlier we have to stick with the cable standards. If a different device, you have to use a crossover cable. If it is the same device, you have to use a straight cable. So all the standards has been faded now, so you can use any cables here. So we'll see what is NIC. Every device has its NIC and MAC address. That's unique for the communication, right? So that's very vital for your local area connection. So we'll see that what is NIC, what is the role of MAC address in the LAN. And we will discuss about what is the difference between a hub, switch, router, and firewall. So we all know now hub is no more used. And here we will see, so what is spanning tree, and what is MAC address table, and how this inter-VLAN communication is happening here. Yeah, we will discuss about that. What is layer 2 VLAN, what is layer 3 VLAN, and all this comes under switch. And switch has multiple forms, and we have a two classification, I would say, for switch. One is multi-layer switch, that works as a layer 2 and layer 3 because it is capable of routing. And the other switch is a layer 2 switch. So we do that in the lab, and we'll see the difference of that. So router, we all know, if you're connecting two different LANs, so you want a router because router connects a different network. So we'll do the lab for routers, and we'll do the firewall is will give you a glimpse of, okay, how exactly firewall works and what is the role of a firewall in a network here. And then comes here in the ARP. So ARP has a different classifications, right? So if people heard of ARP, that plays a very crucial role in your packet forwarding from one place to another place. So without ARP, nothing happens. Right from your PC until you reach the internet, so the ARP has to, it works from the source to the destination. I mean, from all the middle devices has to do the ARP until it finds the destination. The whole objective of the ARP is to find the destination MAC address. So we'll do a lab, and we will do a packet capture in the Wireshark, and we'll see how exactly the packets are forwarded, and what is ARP request, what is ARP response, and what are the details inside the ARP request and ARP response. So we'll do that. The lab, it's a discovery lab. So we'll do an ARP scenarios with packet analysis. Then coming back to the Ethernet frames, we discuss about the history of Ethernet. So that's been moved now from LANs to VXLANs. So yeah, but we are not discussing a VXLANs here, but here we'll discuss about what is the role of Ethernet, what is CSMA CD, and how do you check some errors, and we'll do a lab for the same. We'll do everything, and we'll have a theory and lab session. Followed by that, we'll discuss that. And coming to the IPv4 address, IP plays again the key role. So every host has an IP address. So irrespective of what application you use, the packet delivery happens with the IP. If I want to reach google.com, it should have an IP address. If I want to reach facebook.com, what exactly I have to go to the facebook.com because it has a unique IP address. So here we'll discuss about IP addressing, what is private IP address, what is public IP address, and we'll discuss about what is subnet mask, wildcard mask, what is CIDR, classless interdomain routing, and then we will discuss about how to use the subnet calculator if you have a huge network and how you're going to segregate your network. So we will show you how to use a subnet calculator, and followed by that, the AND operations, what's used when you exchange a packet. We will discuss this in detail in the lab. And here again, the analogy of IP header, not only with the IP routing, I mean IP communication, it's not only limited with that. We'll go to the anatomy of IP header. So we'll open the IP header, we'll see what is fragmentation and how reassembly happens from end to end, and what is layer 2 MTU, what is layer 3 MTU. And also followed by that, we'll see TTL, time to leave. So why TTL plays a crucial role here. Even in the demonstration, I'll show you where in the layer 3 network layer you can find your TTL values and all this header inside that Wireshark. So followed by that, ICMP has a different types and codes. If it is an unreachable, it is a different code. If for destination is unreachable, it's a different code. And if there is a no communication, it's a different code. For every use cases, we'll do a lab and test. And here comes the ping. So we'll see what exactly the ping request and ping reply in the Wireshark. We'll see with the identification number, the ping uses a special value called IP identification. Example, if you send 4 pings, each ping request has its own identification number. So in the Wireshark, how I am going to find the 4 pings? It can be a 10 pings, but what if I lost the 10th ping here? So identification is a unique ping number given for every ping request goes from your computer, or maybe your destination and from your source whenever you're trying to do that. And some boxes and Cisco boxes, they use UDP based trace route. Some boxes they use ICMP based. So how to differentiate that? So Cisco uses all with 125. The Windows is using 128. Yeah, Windows is using 128. So I think the Linux uses a 64. So that's the maximum TTL. So if every product, I mean, every device, it uses a different protocol based trace route. So we'll see the difference between that. Then followed by that, yeah, as I told you, the ICMP based trace route here. And we'll do this in the discovery lab. And followed by that, TCP and UDP. TCP and UDP plays a, I mean, that's a, I mean, the key for moving your packets, right? So TCP and UDP, I would like to start with, it's a transport. So I have my IP, I know my source, I know my destination, I have my application, but how do I deliver this? And what kind of application is used in the other side? Yeah. So let me give you a simple diagram for this. You guys can understand better. So for a transport, so I got a packet here. So I got source IP, I got a destination IP, I got source MAC and destination MAC. So the example, this destination is 20001 and this source IP is 20002. So if I send this packet out, so what is my transport? How do I reach here? So what protocol is used? Example, here I am using a HTTPS. So my application is a web browsing here. So for HTTPS, we know it's a well-known port and it's port 443. So my source port is a random port. So this is all well-known port. So example, my random port number here, 56182. All this wrapped up here. And my destination port would be 443. So who handles this? This is handled by TCP. So all this information once before sending that, I'm going to send a SYN message, right? This is the destination. There is a web server and the port 443 is open here. So when the request comes through, I should see the SYN ACK back, right? I should send a SYN. Sorry for that, let me delete this. So for this SYN, the web server will send a SYN ACK back. So I want to acknowledge, yeah, I got your SYN. That's called ACK. SYN, SYN-ACK, ACK. This is three-way handshake. And most of my experience I have seen, even in the Palo Alto, if you open a protocol like, okay, I open a port only for SSL application. But if you see the TCP handshake there, you would see an unknown. So if your three-way handshake is not happening, even though if you open the port 443 for SSL application, then it could be most probably it could be a routing issue here. Because if the lower layers are not working, even though if I open an application protocol, that's not going to work. I should see a successful TCP handshake before moving to my application. If your routing is not happening, your application communication will never happen. So this will replicate, we'll do this in the lab, and we will see the difference. So this is three-way handshake, and there are multiple headers and options inside. So we'll discuss about that, and we'll discuss about what is window scaling factor, window size. These are all the parameters of TCP. Example, if you see the 0 windows, example, if I say here, let me take a whiteboard for the better representation. So as I told you, this is a source. This is the destination. So the very first packet in TCP communication, and more important, this is a peer-to-peer communication. So this source 10.0.0.1 and the destination would be 20.0.0.2. So when I'm establishing connection, as we discussed, I will send a SYN. For the SYN, I should get a SYN ACK from the destination from 20.0.0.2. For this SYN ACK, I'm going to acknowledge back. Yeah, I received your SYN ACK. This should happen only then, whatever the application, if you open your SSL or whatever, it should work. If this TCP is unknown, your communication is not going to happen. So we are coming to the 0 window here. So I established a connection. So I'm transferring a file from here through FTP. FTP uses a TCP protocol. So I send a 20 meg file, maybe 20 MB file example. So now my connection established. So I'm going to look for the port 21 is opened for FTP communication on the server. Let's imagine this is a FTP server. But if we talk about the window size in TCP, example, this window size now maybe it's also receiving traffic from the another destination. This is sending some data here, back and forth. So this server is busy, and my window size is, I have no buffer to receive any more data inside. So you have to wait. So it's going to say TCP window 0. So what happens here? Once this particular communication, if this is busy, if my communication is established after this green transition here to differentiate. So once this green color PC, if it finishes the communication with this, my TCP window size gets bigger now. Again, now it is open. So now I can send the files. So with Wireshark, when there is a window problem, you can see if there is a congestion. When you open the TCP header, you can see that. So this is how the Wireshark helps you to figure out. So this is, you cannot do that with just router CLI or your firewall CLI, right? So I have seen certain scenarios where the server is very busy in receiving multiple requests and there is a congestion. And how do we find, and how do we say this is because of a congestion? It's a problem. It's not with a routing issue. It's because of a server. How you can confidently go and talk to the server team. So it helps us to figure out. Let me hop back to my slide. So yeah, in the same way, we discuss about what is sliding window, what is window size, and what is MTU, maximum transmission unit. So whatever the data you have, you cannot send your traffic more than 1,400 bytes. Because the MTU is designed with 1,400 bytes, right? Sorry, it's 1,500. So that's how it designed. So what is IP MTU? We will see this in the lab. And we discussed this. And in the TCP flags, you have multiple flags. So you have SYN, we discussed about that SYN, SYNAC, and FIN. I mean, FIN, once both communication is happening, and it's a gracefully both end are terminating the connection here. That is FIN. And if something happens in the, if something happens and I want to send this data very quickly compared, and I want to prioritize this traffic, we'll use the urge pointer here. Urge flag. When you open the TCP header, you will see that if it is a SYN is marked as 1, and if the other options are not being used, you can see zeros not used. So we will discuss everything in detail. So what is flow control? What is slow start? What is retransmission versus fast transmission? So retransmission is a key. Let me tell you. So let me again jump to my whiteboard. I have seen this scenario multiple times. You have your server here. Sorry, this is a client. This is my client and this is my server. And it can be your switch or it can be your firewall, anything. And you have your server here. But predominantly every time we use a switch for connecting the end device. But if your design is something you are going through the firewall like this, and you have a switch again here, and you have a server, and all my L3 sits in my firewall. For this server example, it's a DMZ. Just for an use case, I'm telling this is an DMZ. So I'm using an IP address, something like 162.7.8.1. This is my gateway. So this server, this is my switch, and this purely an L2. I'm using a VLAN 350 here. So this particular server in the switch, I made this port as access port 350. So for this server, my firewall is the gateway here. So what happens here, this client is trying to establish a connection with this server. It can be anything. Okay, let me tell you. So it tries to establish a SSL connection here from this client to the server. So what if the port is down? If I ping from this server, I cannot reach this server. If you look from the Wireshark perspective, it's going to tell you, you can see a lot of retransmissions. Lot of retransmission, not one, multiple retransmissions, hundreds of retransmissions. So why is that? I'm trying to establish a TCP connection here. I'm going to establish a TCP connection. As I said, this is peer-to-peer. This PC is trying to establish a TCP connection. However, this particular server is down. So I'm trying to reach the destination. The destination is not reachable. So for my SYN, I never heard my SYNAC back from the server. Never ever I'm receiving a SYNAC back. So this guy client is keep sending retransmitting. I'm trying again and again. I'm trying to establish a connection. So we can figure out, okay, this is a retransmission is happening, and is it my reachability is there? So this is a very small network. You can think, okay, I can go and ping the firewall and can find it, right? What if it is a big network? And with this, because of the peer-to-peer communication, you get the spotlight, and it's like a spark, and you can figure out, okay, retransmission is happening, there is no routing. You will check inside the switch, is it my routing is good, I can reach the firewall, but I cannot reach here. I can do a trace route. My trace route is dying here in the firewall. After the firewall, my traffic is not going to the server because the server port is down. With this retransmission, you can spot. So it's like that. So let me again jump back to the course content here. So that is retransmission. We'll discuss about the fast retransmission in the class and the selective acknowledgements. So when I talk about the selective acknowledgements, the biggest advantage of selective acknowledgement is that, so we are going back to the same use case here. So this is my client and this is my server. So my TCP handshake is successful. My SYN, my SYNAC, and I received a ACK. So this is successful now. Selective acknowledgements. I missed that part. So here, selective acknowledgements. Okay, coming back to that. So for every SYN packet, I'm receiving an acknowledgement. What if there is a stream? Example, I'll tell you, if I am going to communicate to this web server, port 443, my connection established. Yeah, we all know TCP is a 4-tuple connection. First thing I should know about the source IP address. So here it is 10.0.0.2. My destination IP address is 20.0.0.2. This is 10.0.0.2. And source port is a random port, 4231. And the destination port is a well-known port, 443. So as I said, you need these 4 parameters to successfully, if you want to send the data from source to destination, you have to have all these 4 parameters. Otherwise, you cannot, move your packet. You cannot push your packet. It's not going to reach there. So I established this connection. So I am telling here, so this is my stream 0. And in the application payload, it is just send a client hello. So I am waiting for the server hello here. And the same stream 0. Again, the same 4 tuple connection, it's coming back. Example, what if in the stream 0, I lost some packet in the middle? So I cannot resend the whole packet. Example, if it is maybe a 2 MB of data payload, but I am missing something in the middle. So 1 MB of data is successfully reached and it's arrived to the client. They left out 1 MB. So I cannot send the 2 MB file again. It's a repetitive process. But instead, TCP is using an option called selective acknowledgement. So using the selective acknowledgement, it's going to say, I didn't receive in the stream, I didn't receive this 1 MB of data. Can you please send it back again? So I am sending an acknowledgement for that specific lost data. For every SYN, you have a different sequence number and different acknowledgement number for every stream. So imagine this is a second stream. I lost some data. So my sequence number, let me take a different color here. My sequence number is example 7621. For this sequence number, I didn't receive the data. I cannot send an acknowledgement because can you please retransmit this? So that is selectively I'm requesting from the web server to send the data back again because I didn't receive. Yeah, Indu, we will discuss everything, after this. This will break the flow. Yeah, I remember that. You can definitely ask questions to me in the Q&A.
Praveen, little bit loud actually. Some people are saying that your voice is little low. Just be louder.
Okay,
Everything else is okay.
cool.
Maybe
Yeah,
check your speakers or something. You just be louder, please. That's it.
okay,
Other things are good.
cool. Okay. How about now with it? Is it fine?
Yeah, go ahead. Try to be loud, okay?
Yeah,
As
yeah.
much as you can. Thank you.
Sure. Yeah, no problem. Yeah, guys, I mean, yep, sure. If you can't hear me, yeah, definitely you can, raise your concerns. Yep. So this is the use of selective acknowledgement. So going back to the TCP timers, so there is a predefined timers where if the packet is not reached the destination, it's going to wait for the timer, and if the timer fails, and it's going to send a retransmission. So retransmission is never happen just like that. So it waits for the timer, and we'll see how this TCP timers work. And RTT, when it comes to the RTT, it is a round trip time. Round trip time is very crucial and it's very important to understand your network performance. Let's again go back to one more use case here. So all falls into the TCP again. TCP, this is source and this is the destination. So RTT stands for round trip time. So round trip time is purely calculated on SYN and your SYNAC. We'll see this in Wireshark. So the moment which I send, everything happens in the network in the, in the matter of milliseconds. So it took 260 milliseconds to send my SYN from here. So I received the SYNAC back in 290 milliseconds. This is how you will calculate. So, but if it jumps beyond this example, if it takes 2 seconds, it's really a very bad connection. So just using the SYN and SYNAC, you can figure out, do you have any kind of network problem? And if there is a spike in the, if there is a spike in the time taken, then you have to concentrate and you have to dwell into your lower protocols, your layer 3 and layer 2. It can be a interface error, it can be a bad cable, or it can be a routing loop. Yeah, it happens. So even TCP is very intelligent to figure out if I send a packet from, this is just a peer-to-peer and we have a topology like this. What if we have a topology something like this? From this source, I got a multiple egress point. So here I got 2 connections. I got 2 ISP links. So if there is a routing loop, hop by hop, the packet has to go like this. And the packet should come back in the same way. Up and down, upstream and downstream should be in this using the same path. But what if my traffic is going like this upstream and the downstream is coming back like this? The TCP is going to tell you that this out of order packet. You can figure out this is a routing loop. So that's the beauty of TCP. So that is RTT, idle timeout, and persistence, keep alive. Everything we'll discuss in the class. So now let's move a little fast with other protocols, and we'll relate the relationship between maximum segment size and your threshold round trip time again, UDP, and what are the other protocols that's predominantly using for UDP. So far we are discussing more about TCP, but UDP, it's connectionless and reliable. If I keep sending a packet, I keep sending a packet. I don't mind even it is not reaching the destination. And we will see the difference between what is TCP and UDP and what are the other protocols used, the logical common port numbers. Yeah. Followed by that, DNS. We all know DNS is super important to forward your packets because you cannot imagine every website IP address. It's hard. So let's jump into a quick background about DNS. People who are really experienced and who, they have a more insight and understanding about DNS. You guys can skip it because this is something I'm trying to fulfill everyone, because people might be from a different background. Maybe there might be some freshers here, and guys may be experienced. So yeah, bear with me. Just a quick overview about the DNS. For that, let me again jump to my whiteboard here.
So, Praveen, I would request you to cover DNS through capture so that they can understand, because all know how DNS works. So if you can cover it through Wireshark captures practically, that would be helpful. Now, I would request for next 15 minutes, if you can cover practical knowledge, like how we'll be delivering this tech level packet capture training. So that will be helpful. You can cover DNS. I want you to cover 3 scenarios. Most of the people are facing issues like transferring a file from one side to another side. They get slow transfer rates, frequent disconnection. And another issue which people face is slowness issues. So how you will troubleshoot when websites load very slowly or when it fails to load. So you cover this scenario with all the things either related to network analysis, firewall logs, DNS resolution, ISP, what can be issues through packet capture. That would be really helpful for others because most of the people like experience. So just open capture and show them when you access any page. So two scenarios, if you can cover, that would be really helpful.
Yeah, sure, no problem. Yeah, we'll do that. Yeah. So let me go back to my captures. Okay, let's take a slowness issue here.
So great. Because this is a headache for everyone right now, whether it's a network engineer, cloud engineers, or security engineers. People are facing issues, slowness issues very much. So what things we can check, how we prove it's not a network issue. So that is one main concept. So how you will help them to understand.
Yeah, sure. Definitely with it. Yeah, we can do that. Yeah. So maybe yeah, we you guys are experienced, so you know how Wireshark works. So let me give you just a simple the customization what I did here. So here I always prefer the delta time to find my slowness issue all the time. So delta time is time since when I send a packet. It's going to show me that. That's delta time. Here I mark my source IP, I mark my destination IP. I gave a little tag here. And what are the protocols used? This is all default and TCP segment length. We'll discuss about that. And what is TTL? What is sequence number? Acknowledgement number? Then again, here is the information. I mean, what are the ports used when I'm sending a traffic? Got it? So that's it. So we are going to start this. So let me take this. This is one of the iPerf I did iPerf. I mean, that's a tool used to find your throughput. If somebody is telling that my download and upload is very slow, just with a speed test URL, I mean, that's not very super accurate, I would say. So I always prefer the iPerf tool. Maybe you guys might be used here because that helps you to figure out my individual PC, how much data I can send in a second. Yeah, that will give definitely good detail about that. So with Wireshark, I captured the logs. So let me take this scenario here. Let me try to figure out. I did this conversation filter, TCP. Let me go back to the top. Yeah. So from my PC, and this is an iPerf server, my destination here. For my SYN, if you see, it starts with 0, like your timer, your stopwatch timer. So it starts from 0. It took 536 milliseconds to reach my SYN pack. So as I told you, if you see a spike here, example, if you see all the values here, scroll down, you have to spot, is it something here in the delta time? I can see a spike of 1 second, 2 second. Here it's definitely good. But if there is a slowness, you should apparently see the first digit here, something spikes to 3 seconds, 2 seconds, sometimes 10 seconds. So if you look at this in the segment length, what is the payload I sent here? 0. I didn't send anything in my payload. This is all the header values here. So I didn't send anything. So the TCP segment length is 0 here. So it is just a SYN. And how do I know this is a SYN? So we got 3 layers here. So through this, I can figure out, so the destination is listening on port 5201. Source port is this. As I told you, the stream index. This is the 37th conversation. And how do I find this is a SYN? You have to open a flag. You have to drill down here. You see this is, as I said, you see this is marked as 1. Only SYN is set, nothing else. So we saw some ECN echo. We'll discuss this in the lab. So for now, this is SYN. So SYN is marked and I send a SYN. So now if you see, the value is reversed now. So from the server, I got a reply back, acknowledgement, SYN ACK. For the SYN, what I sent here, I got a SYN ACK back. Again, if you see the TCP segment length, 0. Nothing. So far, what I'm trying to say, no packet is exchanged. It is just trying to establish a connection. So what if the server is down? You should see a lot of retransmissions here. And if you open this quick filter, I would say this is super important filter here. If you click on this, and if there is any problem related to retransmission, your errors, this will give you an insight, a complete high-level insight. So if you see here, as I told you, it jumps right away to this packet. See what it is telling here? My TCP window is full. So my question is, with just a TCP dump, I don't know, I mean, but I haven't seen this, but I use a Wireshark for this. Just with a one click, I can figure out how many packets and what is the stream where exactly the congestion happened. It is complaining. If you look at here, it's a warning messages. Your TCP window is full. I cannot receive any traffic here. So for this, again, it has to send it back. So who is sending this? So I am dumping the traffic. So here my source, my computer is keep sending traffic, right? Because I'm pumping the traffic to check my connection, iPerf. So my PC TCP window is full here. I can conclude my PC doesn't have a TCP window, no sufficient space right now to receive your data. So here you have to look, this is the key. So who is sending this TCP window size? Just with this one click, I can straight away jump in, I can go find this. Now you should analyze why my computer is doing that. Is it normal? Is it my PC sending other traffic? What are the other connections? And if you look at this, this is a FIN packet we discussed about. So this is a graceful shutdown on both ends. So the server is telling, okay, we are all done with the communication. We exchanged all the data. So it's time to tear down the connection. If you open this, and if you go to the TCP flag and you shoot the FIN packet is set. And if let's try for any reset packets here. So right now I can't see any reset, but maybe in the firewall rule, example, if I'm trying to establish a connection over 5201 here, this is my source, right? 5338, and it is trying to establish a connection on port 5201. And if this port is closed, I should apparently see a TCP reset here. Let me check. I think I don't have a TCP reset. Uh, okay, so here's a warning of reset. Yeah. So my computer is resetting the connection here. If you look at this, if I open this, I go to the flags, reset smart here. So I always use this as I would say the superpower tool here. This will give a complete glimpse. So here, see that there are a lot of DNS response retransmissions. I didn't get a DNS response back here. I told you the selective acknowledgements. So keep alive. Is it my connection is still active? Keep alive. It's like a complete in capsule. So you have to really dwell deep into the TCP to understand that. So as I told you here, you can see the out of order packets. You can see all these warnings here. So it's not coming back from the same place. There can be a routing loop here. And how do I actually concentrate much with this? First, let me go and I'll check, is it my TTL is decrementing? So then definitely there is a routing. If there is no routing, my TTL will never decrement. Yep. So this TTL is 128. So here 7 hops. So from the source to destination, there are 7 hops. And then definitely there is a routing. And otherwise this packet wouldn't be arrived here. So the TCP out of order happens when this destination is trying to reach my computer. You can see this multiple times. But I don't see this TCP out of order from my computer to this destination. There could be a problem with the routing loop. So this gives you, I would say you cannot conclude anything with this, but Wireshark help you to figure out where is the problem. It helps you to spot, okay, let me look this. It can be a routing issue, but just with ping and trace route, I don't think you will get the level of detail what Wireshark is giving you. I don't think you will get it with your trace route output, in my experience. So that's it, guys. So we'll jump back again to the. This is just a glimpse here, but we will go deep and deeper in the real classes. This being a demo, and yeah, we will giving a very high level, very high level. And coming back to this, we'll discuss about DHCP, headers, messages, everything. Whatever you have here, we have a lab for that. You know, the DHCP relay, then switching, all concepts, ARP, the one queue, interVLAN communication, spanning tree, multiple switch scenarios with access links and trunk ports, link aggregation, how load balancing happens in link aggregation, routing logics, what is the difference between distance vector, RIP, OSPF. Yeah, but everything in a packet level. That's the difference here. In OSPF, what is not so stubby area, what is stubby area, and maybe we never used to show IP OSPF database command to see what kind of LSAs I am receiving and what is my LSDB and what is the other LSDB. How do we troubleshoot that with use cases like this? And we'll do a packet capture and we'll see the NSSA summaries, exchange, LSA information. Okay, I receive LSA type 3, but not LSA type 7. What could be the problem? Yeah, it goes too deep about one specific protocol like that. And we all know about BGP. And again, we'll discuss about the BGP states. Yeah, open state. BGP open state and what is NLRI, BGP messages, what is the difference between eBGP, IBGP, BGP AS path, what is stateful firewall, what is stateless firewall, what is session table, yeah, and firewall implementation in transparent mode and L3 mode, what is zone-based firewall, and we know NATing. So you guys are pretty familiar. So this is all very, very packet level about that, different types of NAT, source NAT, destination NAT, then how packet flows through the firewall, and how do we check that? What is TCP sequence check? What is TCP sequence check? TCP SYN check, sorry. And what is UDP? What is ICMP? And ACLs, how it's configured in the firewall. And VPN is, we are really going deep about that. So what is certificate authority? And using the OpenSSL, how do I separate my, from the PFX file, how I'm going to separate my private key with and certificate? Yeah, we'll do that in the lab. And in the IPsec tunnel, we know the IK exchanges and what is the role of Diffie-Hellman key, what is session key, how it establishes, and how this wraps up again with ESP and send it back, and how do I see that in Wireshark? Yeah, and troubleshooting use cases for IPsec phase 1, phase 2, and followed by that SSL. We all know SSL, how crucial and important now, because everything is running on top of TLS now. So we'll go deep level about every SSL package. It's not just limited to just client hello, server hello. You know, sometimes you may see certificate unknown issue in the Wireshark. It will show you. But right now I don't have a capture, but you'd see a warning here, certificate CA unknown. So it means that your certificate authority, you do not have your root certificate installed, but there with the help of that, you can spot. I found that like that maybe 4 or 5 times. It's a scenario when the voice device is trying to establish a connection with Microsoft. It was when we did a capture in the SBC audio codes, the people they gave us, I did the analysis and I figured out that that's an unknown CA. Then, but they said I have a certificate installed, but still I don't know why it's complaining that unknown CA. Then, we were told by the tech support, maybe the server certificate is corrupted. You guys can give a try by removing the root certificate and install it again. Once we did that, and when we did a packet capture, the SSL handshake happened very smoothly. We can see client hello, server hello, and the application traffic and everything went very well. So what I'm telling is, without this, people they're troubleshooting. I'm not saying, but this Wireshark is a quick solution for you to spot your problems right away. Yeah, that's it from my end, guys. Now we will, unmute you for the Q&A session.